after that, I learned as well.
We're going to start by reviewing some addition and subtraction facts. Caden, come capture the boys' cards. Kathleen, come capture the girls' cards. Go around for me, please. And then we're going to start on this side. Not yet Jimmy. So I'll have Jimmy and Madison to come to capture these cards or give me the answer. And then whoever gets it correct can be the one who captures it for your team. Students watching, you be ready to give me some fast answers as well.
8.
Boys, next two. Cadence.
6. 8.
Girls, next two.
13.
Good. Emily, next two.
7.
Boys, next two.
11.
Girls, next two.
13.
Boys, next two.
14.
Boys, next two. Amaya.
3.
Boys, next two.
3.
Boys, we're here faster. Josh.
4.
Girls, next two.
1.
Boys, students watching. Fast thinking. Next two. Jimmy and Madison.
4.
Boys, next two.
9.
Girls, next two.
1.
Boys, we're here faster.
3.
Girls.
11.
Boys, next two. Tyra, you're up with Arthur.
13.
Boys, next two. Morgan.
3.
Boys, next two. Amaya.
8.
8. Boys, next two.
14.
Boys, next two.
5.
Boys, next two.
15.
Boys. And this is for students watching. Anyone? Tyra?
13.
Yes. All right, let's check to see. Count the boys' cards, count the girls' cards for me. And while they're doing that, we're going to do our 3 multiplication family. We're going to sit and then stand. So we're started seated for our first fact, 0 times 3. Together begin. 0 times 3 equals 0. 1 times 3 equals 3. Jimmy Lights. 2 times 3 equals 6. 3 times 3 equals 9. 4 times 3 equals 12. 5 times 3 equals 15. 6 times 3 equals 18. 7 times 3 equals 21. 8 times 3 equals 24. 9 times 3 equals 27. 10 times 3 equals 30. 11 times 3 equals 33. 12 times 3 equals 36. All right, Jimmy, lights for us. And how many for the boys, Caden?
20.
And how many for the girls, Kathleen? So it looks like the boys are our winners. Boys, you may give yourself a pat on the back. Excellent job. You may be seated. We're going to go through some more of those multiplication facts when I call your row. So students watching, you be ready to join row 2. Row 1. Answers, please.
6.
Good. Row 1.
22.
Good, Cadence.
33.
Good, Cadence.
1.
Nice job. Row 3.
0.
Good, Caden.
10.
Good, Morgan.
16.
Yes.
20.
Good, Tyra.
8.
Yes, Aiden.
16.
Good, Arthur. Row 2.
6.
Good.
12.
Yes.
36.
Good, Jacob.
4.
Good, Emily.
20.
Yes.
9.
Yes.
0.
Ooh, fast answers. Row 4.
21.
Yes.
18.
Good, Dev.
15.
Yes.
14.
Good.
28.
28 is right.
9.
Yes.
6. 22.
Row 5.
33. 1. 0. 10. 16. 20. 19.
18 is right.
16. 6. 12.
Good speed, Asa. And just when I call your name, Carson,
36.
Arthur,
4.
Tyra,
10.
Adriana,
9.
Gage,
0.
Una,
24.
Jacob.
18.
Good. Jackson.
15.
Madison.
14.
Presley. Help him out, Jimmy.
28.
Good. Presley.
28.
Yes. Emily.
6.
Arthur.
22.
Kathleen.
36.
Good. Dev.
1.
Anna.
0.
Josh.
10.
Asa.
16.
Carly. Help her out, Amaya. Girls, read it for me. 5 times 4.
5 times 4 equals 12.
Good. Again.
5 times 4 equals 12.
Good thinking. Now we're going to go through some of our division facts. We're going to start by giving the answers as a team just by your rows, like we just did for our multiplication facts. So let's start with row 3. Row 3, Stan.
0. 12.
12 is right.
1.
Good.
0.
Yes.
1. 2. 3.
I like that speed. Row 2 and students watching.
4. 8.
2 is right.
4.
4 is right.
5.
Good.
6. 7. 3.
3. Good, Emily. Row 1.
4. 8.
Yes, Cadence.
10.
Not 10. 5.
6.
6 is right.
7.
Good, Cadence.
8.
Good.
9.
I like that speed. Good thinking. Let's go over to row 4.
7.
Good.
9.
Yes.
10.
10 is right.
10.
Good, Dev.
11.
Yes.
12.
Good.
11.
11 is right.
0.
Good, Dev. Row 5.
12.
Yes.
1.
Good, Asa.
0.
Good. Cadence.
1.
Yes.
2.
Good.
3.
3. Good, Cadence.
3.
3. Good, Asa. Nice job. At this time, I want you to listen to some of the facts that I read. Be ready when I call your row to pop for our rapid calculations. 2 plus 2 plus 2, row 3. Arthur.
6.
Morgan.
6.
Cadence. 6. Be ready to have that answer right when you pop. 4 plus 4 plus 4, row 2. Emily?
12.
12. Good. Students watching, if you said 12, your answer is correct. 4 times 5 plus 6, row 1. Cadence?
26.
26 is right. 10 divided by 2 plus 8, row 4. Anyone? Dev?
13.
13. Good. Students watching, if you said 13, you are correct. 4 divided by 2 plus 7, row 5. Asa? Anyone?
10.
Tyra?
9.
9 is correct. 4 times 4 divided by 2. Anyone? Caden?
16.
Carson?
24.
Asa?
8.
8 is correct. Students watching, if you said 8, you are correct. At this time, we're going to prepare for a speed drill. Prepare for your speed drill. Speed drill materials away. Let's review perimeter. As we do so, let's take a look at our chart. Jimmy lights for us. At the top, you see the word perimeter. The perimeter equals the distance around a geometric shape. Look at that first shape, the triangle. You have 3 feet plus 3 feet plus 3 feet for that triangle, which equals 9 feet. Look at the rectangle. You have 4 inches plus 12 inches plus 4 inches plus 12 inches. The distance around the perimeter equals 32 inches. Let's take a look at the chalkboard and find out some of the perimeter on some of these objects that I have at the front. Jimmy, you may turn on the lights for us. Let's take a look at this first triangle over here. To measure, or to find the perimeter of this triangle, we need to find the distance around. So we're going to start on the left and go completely around, measuring all the lines. But as you can see, some of these lengths could be a little bit longer than the 12 inches on our ruler. So I brought with me today the yardstick to help us measure in case we have sides that are longer than 12 inches. So I would like Asa and Carly to come to be ready to read to help me find the perimeter for these inches, or for these sides rather. Let's take a look. We're going to start here, and Asa, come and find what number about does this first line equal?
16.
Not quite 16. Right here, that point ends at the
15.
The 15, yes. Well, not quite a half yet, just 15. Thank you, Asa. So we're going to use just the 15 as the number of inches for that first side. So Carly, come take a look at this next side and tell me about how long this next side is.
15.
All right, so it is 15. Thank you, Carly. So we have 15 for this side. And Josh, come and read this last side for us. I'm going to hold it up. You tell me how long. It is 15. So we'll put 15 inches on this side. In order to find the perimeter, what must I now do with all the lengths, Dev?
Add them.
Yes, so I'm going to add them together. I'm going to take the 15 plus the 15 plus the 15 and combine them together by adding. So add the number when I point to it. 5 plus 5 is? 10. Plus 5 is?
15.
Good, so I will write the 5 here, add the 1 to the top of the next column. Let's continue with 1 here. Ready? 1 plus 1 is?
2.
Plus 1?
3.
Plus 1?
4.
So the perimeter is what, Tyra?
45
Yes, but 45 what, Anna?
inches.
So I'm going to write 45, but then I'm also going to use the inches sign beside it to remind us that this perimeter is 45 inches. Now let's take a look at our next shape, and let's have Anna, Lexi, and Dev come around and be ready to give me some of the lengths for these sides. First of all, we're going to do this side, and we're going to go around clockwise. I'm going to start this way at the bottom vertex here, and then Anna, come tell me how tall this first line is.
24 inches.
Yeah, so this first line is 24 inches. All right, come read the top for me, Lexi. It is 12, thank you, ma'am. So I'm going to write the 12 on the top. And let's do our next side. Dev, you can read this next one for us.
24.
It is 24, so I will write the 24 down here. And the last one down here, Kaden, come read that last one for us.
12 inches.
It is 12, so I'm going to write the 12 down here at the bottom. And we have here 12 inches. Now what must I do to find the perimeter, Gage? Add all of the numbers together. So we're going to start with the 24, and we'll write that one first. So we'll do 24 plus the 12 plus the next 24 and the last 12. Then I add them together. We're starting with the ones column with the 4 on top. 4 plus 2 is?
6.
Plus 4 is?
10.
Plus 2 is?
12.
12 is correct. I'll carry my 1 to the top of the next column. 1 plus 2 is?
3.
Plus 1 is?
4.
Plus 2 is?
6.
Plus 1 is?
7.
7. So the perimeter for this rectangle is what? Amaya?
7.
70?
72.
72 what, Arthur?
Inches.
72 inches is correct. And there I have that final perimeter for the distance around the rectangle as 72 inches. That's the way I would find the distance around something. So the perimeter is the distance around. When I say perimeter, you say distance around. Perimeter?
Distance around.
Good. Now let's take a look at some of our geometric shapes that we've talked about and listen as I ask some questions about the different shapes that we have to look at. The first shape that we're going to take a look at is this shape where all the sides are equal length. What shape is this, Anna?
Where?
How many vertexes does it have, Dev?
4.
How many right angles, Arthur?
4.
Good. What shape is this, Morgan?
Parallelogram.
It is a parallelogram. How many vertexes, Emily?
4.
How many right angles, Cadence?
9.
There are. Remember, a right angle are where the two sides, the two vertexes meet, and they form a square. Oh, let's take a look at this one. This parallelogram, you're right, does not have any right angles. This parallelogram is slanted. So you're right, Cadence, there are no right angles. Slanted, it doesn't have any right angles. What shape is this, Carson?
A pentagon. Rhombus.
It is a rhombus. How many vertexes does it have, Adriana?
4.
Right. So there are 4 vertexes. Does this rhombus have any right angles, Morgan?
No.
You're right. It doesn't have any that would come together. It is a kite. How many vertexes does a kite have, Tyra?
4.
Good. What shape is this, students watching? And what is it, Gage?
Trapezoid.
It is a trapezoid. How many vertexes, Jimmy?
4.
How many right angles, Presley?
2.
You're right. It has 2. What do we call this shape, Aiden? It is an oval. Does it have any vertexes, students watching? And Anna?
No.
Not at all. What shape is this, Josh?
Triangle.
It is a triangle. How many vertexes does it have, Josh? 3. Are there any right angles in this triangle? Cadence?
No.
No, you're right. What shape is this, Kathleen?
The circle.
Good. Does the circle have any vertexes, Josh? No. Does it have any right angles, Josh?
No.
What shape is this, Carly?
Rectangle.
Good. How many vertexes, Amaya?
It has 4.
4. How many right angles, Lexi?
4.
This is the one with the 4. This shape is a what, Jacob?
Diagonal.
Good. How many right angles in this shape, Adriana? None. How many vertexes, Jimmy?
4.
What shape is this? It is a shape that has 5 sides, and it's called this because it has 5 sides. Dev? Good. Now, how many vertexes does a pentagon have, Josh? It's the same as 6 sides, Jimmy.
Hexagon. 6.
Good. Are there any right angles, Carson?
No.
No. Now, does this shape have parallel lines? Jacob?
Yes.
It does. What shape again is this, Josh? Does a square have parallel lines, Gage?
No.
Think again.
Yes.
Yes, they do. The right side and the left side, and the top and the bottom both have sets of parallel lines. Now, as we go into the next part of arithmetic, we are headed into the kitchen. As I was baking, I made several dozens of cookies, and I have 36 cookies today that we are going to split between 3 cookie jars. So I need Madison, Adriana, and Emily to come help me with my 36 cookies that we have to divide between 3 cookie jars. So we are going to put our cookies into 3 groups. So girls, hold out your hands for me. Why don't you step forward to the middle here for us? And then I'm going to equally give them all the same amount of cookies. Let's count as I place them in their hands. We'll start with Madison. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we double checked. I have 36 cookies. Girls, put each of your cookies in your cookie jar, and we're going to find out the fact. What is the number 36 divided equally among 3 jars? Now, as we are putting these into groups, we are looking at a division problem. We started with 36. We are dividing by 3, and eventually we'll find our answer. As we take a look at a division problem, we have the terms dividend, divisor, quotient. Let's say them together. Begin. Dividend, divisor, quotient. The dividend, Gage, is the number we start with, Presley. The divisor is the number of groups, and the quotient is our answer, Josh. So let's say them together. Begin. Dividend, divisor, quotient. What do we call the answer, Josh?
The quotient.
Good. Now, another way that we could write this division sentence is with the house, and then the person outside, and then the answer on top. Dividend, divisor, and quotient. The dividend, still, Josh, is the number we start with. The divisor is still the number on the outside, and the quotient is the answer. The divisor is the number of groups, rather, and the quotient is the answer. So let's say those terms again, starting with dividend. Ready? Dividend, divisor, quotient. What do we call the answer, Josh?
Quotient.
The quotient. Let's take a look at these groups of cookies these ladies have placed in their cookie jar. How many cookies do you have in your cookie jar, Madison?
12.
How many do you have, Emily?
12.
And how many do you have, Adriana? Thank you, ladies. You may be seated. So we looked at this problem. 36 divided by 3 equals 12. The number of cookies in the cookie jar would be the answer. That's how we can put them into groups of 3 after starting with the whole. Let's take a look at our 3 division family. So looking at this chart, follow along as we take a look at, first of all, Jimmy Lights, please, the number that we start with. We're counting in groups of 3. Let's start with 0 together. Begin. 0, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. Do you see how the number that we start with is the same as with the 3 multiplication family? That's the answer. So basically, it's looking like we're writing it in reverse order. We're starting with the answer, putting it into groups of 3, and then the numbers that we get as our answers, we're counting from 0 through 12. So girls, you're going to start with the fact 0 divided by 3. Boys, you're going to give us the answer. Girls, start. Ready, begin. 0 divided by 3
Equals 0.
3 divided by 3
Equals 1.
6 divided by 3
Equals 2.
9 divided by 3
Equals 3.
12 divided by 3
Equals 4.
15 divided by 3
Equals 5.
18 divided by 3
Equals 6.
21 divided by 3
Equals 7.
24
Divided by 3 equals 8.
27 divided by 3
Equals 9.
30 divided by 3
Equals 10.
33 divided by 3
Equals 11.
36 divided by 3
Equals 12.
Very good thinking as we went through our 3 division family. Great job as you said that with your teams. Now we're going to take a look at some different types of shapes. Let's take a look at this chart. This chart right here shows us something that we call geometric solids. A geometric solid is a 3-dimensional shape. The first one that you see here is a cube. This first one is a cube. Listen and then repeat. Cube.
Cube.
Sphere.
Sphere.
Cone.
Cone.
Pyramid.
Pyramid.
Cylinder.
Cylinder.
Rectangular prism.
Rectangular prism.
Prism. Let's try that one. Rectangular prism.
Rectangular prism.
Good. Now on this pyramid, you see a couple more terms we're going to talk more specifically about. The first one you've already heard when we talk about a flat shape called a vertex. Class, repeat.
Vertex.
The new term we're going to take a look at is the face. It is a face. This part over here is called the edge. Now I'm going to explain these, and I want you to look at these figures as I talk more about them. The first thing that I want you to look at is the term face. The face is the flat solid, or the flat surface rather, of a solid shape. The edge is the line where 2 faces meet. So where both of those faces come together, that's where we have the edge. Now look at the cube. The cube has 6 faces on it. This is in the shape of a square, and it has 12 edges total. Now look at the rectangular prism. That has 6 faces, but the faces are in the shape of a rectangle and 12 edges. It's different because the faces of it are rectangles, not squares. Look at the cone. The cone only has what we call 1 face because it only has 1 surface that goes around it. The cylinder has 2 faces. There's the top and the bottom, and the faces of that cylinder are in the shape of circles. Now look at the sphere. This is in the shape of a circle, except it's round. It's 3-dimensional. So it's not flat. It's more what you would think of as a ball. look at the pyramid. This shape has faces on it that are triangles. So that makes it different from a flat surface because it is three-dimensional. So I'm going to show you some of these, and then you will look at them, and then I want you to repeat the term in just a minute. This part right here is showing us that is where the edge is of that surface. So this is the edge. What is it, class?
Edge.
Good. Now, the flat side of that is called the face. It is called the face. What is it called?
Face.
Good. This shape, again, is the rectangular prism. So look at it. It is the rectangular prism. What is it?
Rectangular prism.
Good. This shape is a pyramid. What is it, class?
Pyramid.
Good. Our next shape we call a cube. This is a cube. What is it, class?
Cube.
Good. This shape right here is a cylinder. What is it, class?
Cylinder.
Good. This next shape is a cone. What is it, class?
Cone.
Good. This shape right here is a sphere. What is it, class?
Sphere.
Good. Now let's take a couple look at some actual examples. Now the pictures on our cards and the pictures on our charts, they look flat because they're printed or displayed on a flat surface. But here you can see this is a cube because it is three-dimensional. It has the height, the width, and the depth. It's not just something that has width and height, but it actually has depth to it. So this is what I mean when I say three-dimensional, because it has height, width, and depth. It has three things: height, width, and depth. Say those with me. Height, width, and depth. And that shows three things, so that's why we call it three-dimensional. And this right here would be my cube. The next thing I have right here is my sphere. This is the sphere. It's round like a ball. It's not flat. Something that's flat would only have two dimensions, but this has depth to it. So this is why it is three-dimensional. Here we have our shape that is our cone. So you see the face right here, or you see the surface here, and then at the bottom, this is the face. That's that flat circle. So this right here is my cone. Right here, I have our pyramid. Do you see how this is a face, this is a face, and this is a face, this is a face? What do I call this point right here where the two faces come together, Josh?
Edge.
Yes, so this is an edge, this is an edge, this is an edge. At the bottom of this pyramid, what shape is this face down at the bottom? Presley?
A square.
Yes, this face down here is called a square. Now let's take a look at our cylinder. The cylinder has the surface here, but then it also has a face here and a face here. What shape are the two faces on our cylinder, Morgan?
A circle.
Yes, this is a circle and this is a circle. Right here, we have our rectangular prism. Rectangular prism. Do you see how this is in the shape of a rectangle? This is in the shape of a rectangle. This is in the shape of a rectangle. So the faces on the prism are in the shape of a rectangle, except there's one exception. On this side and this side, the faces are what, Una? So this, though, would be a little bit different because all of the faces are squares. This one has faces that are rectangles. What makes these different from something like a square, from something like a regular circle, Una?
Because those are flat.
Yes, and these have how many dimensions?
3.
Yes, so because they have those 3 dimensions, that makes it different from just a circle, just a rectangle. What do we call, or Tyra, take care of it, this place right here where the faces come together? What is this, Gage? Emily?
Edge.
Yes, so this is the edge. What is it, Gage? Yes, so we have an edge, and then that flat surface is that face. Take out your arithmetic page. Let's look at page 59 together. Go ahead and write your name at the top. Let's look at 3 as a divisor. You see 15 acorns put into 3 groups, and then you have 5 groups of those acorns as your answer. A flying squirrel can store up to 15,000 nuts in one season. They also eat flowers, berries, mushrooms, and insects. That is a lot of nuts for the entire season to store away in preparation probably for a very cold winter. Let's look at number 1. Divide by 3. Use the mushrooms to help you. So if you're starting with 30, put them into groups of 3, And then how many mushrooms would you have in one of those groups of 3? Lexi?
2.
Good. So finish letters B through K. Look at the chart. You multiplied here, think division. You multiplied, think division. Look at the chart. You multiplied, think division. Not 1, but the answer given was 10. So write the number 10. If you get stuck, look at the chart to help you. Good thinking. Good. If you get stuck, look at the chart. Good. Let's check some of these answers. I'm going to start. You give me the answer that you wrote in the blank. Letter B, 12 divided by 3 equals?
4.
Letter C, 36 divided by 3 equals? 12. Letter D, 15 divided by 3 equals?
5.
Letter E, 9 divided by 3 equals?
3.
Letter F, 24 divided by 3 equals?
8.
Letter G, 33 divided by 3 equals?
11.
Letter H, 6 divided by 3 equals?
2.
Letter I, 18 divided by 3 equals?
6.
Letter J, 21 divided by 3 equals?
7.
Letter K, 27 divided by 3 equals?
9.
Good. For section 2, work accurately as you multiply. Work A all the way through the letter N. You may begin. Good. Double it. Anything times 2, you're just going to double. Like how you are right with me. Don't forget your name at the top. Good. You got the rest of them. See if you can multiply some of those. Good. Then find any of the king zeros. Always look for clues. So 0 you know is going to win, 2s are doubling, and 1s is the other number. So those ones you can answer quickly, then come back to think about those. Good. Don't forget your name at the top. Let's check some of these answers. I'm going to start. You give me the answer. Letter A, 3 times 2 equals?
6.
Letter B, 5 times 4 equals?
20.
Letter C, 4 times 8 equals?
22.
32 is the correct answer. Letter D, 9 times 4 equals?
36.
Letter E, 7 times 0 equals?
0.
Letter F, 4 times 2 equals?
8.
Letter G, 1 times 6 equals?
6.
Good. Letter H, 3 times 6 equals?
18.
Letter I, 7 times 4 equals?
28.
Letter J, 6 times 4 equals?
24.
Letter K, 3 times 9 equals?
37.
Letter L, 8 times 3 equals?
24.
24. Put a smile beside that one if you remember that one. Good thinking. Letter M, 1 times 8 equals?
8.
Letter N, 0 times 5 equals?
0.
Work at that chalkboard, Jimmy, Adriana, and numbers 1 and 2. For section 3, you're writing the number that I say. Letter A, Adriana at number 2, Jimmy at number 1, writing on the chalkboard for us. For the next section, you're just writing the numbers I say, so stay there until we finish. Letter A, 529,643. Letter B, 48,600. Letter C, 800,800. Letter D, 302,410. All right, thank you, chalkboard helpers. You may be seated. Let's take a look at some answers. For the first one, your answer should be 529, 643. So it doesn't look like either of these is correct. You have the first part correct here and this second part correct here. Now let's look at letter B, 48, 600. So both of these answers right here are correct. Let's look at letter C, 800, 800. Good thinking. You may also add smiles to your correct answers. Letter D, 302, 410. If you had that last one correct, raise your hand. Give me a high five. Excellent thinking. Now let's look at section 4, set the clocks. So you're looking at 20 minutes after 5. What would 20 minutes after 5 be, Morgan?
5:30.
Not 5:30, but 5. 20 minutes after it is 5.
45.
No, think 20. What number does 20 stand for? Carson?
20 minutes.
20. So 5:20. Look at letter B, 15 minutes after 2:30. So you have to start at count by 5s till you get to 15 minutes later. What would that time be, Emily?
2:45.
2:45, letter C, 30 minutes before 8 o'clock. So start at 8 and count 30 minutes before. What would that answer be, Tyra? Help her out. Madison? Gage?
7:20.
You're very close. It's 7 something, but not 7:20. Carson?
7:30.
7:30 is correct. 7:30. Now turn your page to the back. This is the geometric solid shape side. Look at the bullet points while I read them. Solid shapes have height, width, and length. The face is any flat surface of a solid shape. The edge are where those two faces meet. The vertex is any corner of a solid shape. So let's look at number 5. You're going to follow the directions as I read them. So the first thing, you're going to trace the edges of the pyramid. So find the pyramid and trace every edge that you have. Now, find the rectangular prism. Draw a dot on the vertexes of the rectangular prism. Now find the cube and write your initials on one face. Your initials are your first letter of your first name, and we're just going to do the last letter or the first letter of your last name. Don't worry about your middle name right now. First letter of your first name, first letter of your last name. Then make a stripe on the curved surface of the cylinder. So find the cylinder, right in the middle, do a curve right through the middle. So take a look at this chart while I trace that curve through the middle of your cylinder. It will look something like this, right through the middle there. Now, find the sphere, and you're going to draw a smile inside of the sphere, something like this. Now, can you see the face of the cone? So on the cone, the way it is right now, can you see the face in this shape, Carson?
No.
No, you're right, because it's on the bottom. So draw an arrow to pointing to where the face of the cone would be. So something like this. Now let's look at our brain booster. When the triangle has moved, did it change in size or shape between picture 1 and picture 2? Look at your paper. For the brain booster, numbers 1 and 2. The triangle moved from corner to corner, but did it change in size or shape? Arthur?
No.
No. This is what we call a slide. So look at number 3. You see a square at the bottom left. You're going to, in box number 4, draw a square on the top right. With your pencil, draw that square and then shade it in with your pencil. There you just completed another slide.